Good evening, everyone, and thank you for joining us this evening for our Consumer Units and RCDs webinar brought to you by NAPIT Trade Association. I'm Charlotte Lee, Head of External Affairs here at NAPIT, and tonight I'm joined by Paul Markham and Gareth Davies, two of our top training guys from NAPIT Training, who will run through the presentation and the subject with you. I'd just like to draw your attention to a couple of points and how to engage with us during this webinar. So hopefully you'll all have a control panel to the right-hand side of your screen, and one of the options will be questions. Within this pane, you can type questions at any point during the webinar, and I'll be collating those throughout. And at the end of the session, I'll put all of them all to Gareth and Paul to answer for you. There's also some handouts in the control panel also on the right hand side of your screen. There are two in there. There's a copy of the complete presentation for you, and there is also a certificate of attendance which you can print off and keep for your records to show that you've been keeping up to date with the latest industry news and regulations in this area. Finally, at the end of the webinar, we'll let it run for a couple of minutes so that you've got an opportunity to download those handouts before we close it down. And there'll be a short survey, and we'd really appreciate it if you could take the time to just let us know how you felt tonight went and whether you found it useful and enjoyable, and so that we can make sure we keep our content relevant for you. There will be a couple of polls throughout the session this evening, just to keep you on your toes, so watch out for those. And without further ado, I'll hand you over to Paul and Gareth to kick us off. Thanks.
Hello there, good evening. My name's Paul Markham, I'm the Senior Training Lecturer at Mansfield.
Hi, and I'm Gareth, I'm also a trainer here at Mansfield.
Tonight we're going to do a follow on really from our expos that we've done around the country. We're concentrating tonight on consumer units and RCDs. These were the topics that seemed to bring most of the questions and issues up around the audience at these webinars, and we thought we'd run with it on this webinar. So without further ado, we'll start on the PowerPoints.
Right. Okay. So we'd like to talk about consumer units because, as we know, a lot of them are now metal cased, and that's because of the introduction of the new regulation in Amendment 3 that places requirements on consumer units in domestic premises, and the two options that were available were to install a non-combustible consumer unit or install a consumer unit inside of a non-combustible enclosure. However, option 2 would also still need to comply with regulation 132.12, that is the accessibility of electrical equipment, so you still need to be able to get into it. Now then, since the regulation came into force at the start of this year, most electricians have simply chosen to install the non-combustible consumer unit type. Basically, it's a metal box. But the trouble is, since going to the metal boxes, we've had some challenges that we've had to overcome. So, such as like what products do we need to use? So that's to help to maintain IP ratings. Also, like with securing the meter tails. And because of the reason why it went to this steel is to help reduce the risk of fire. So, do we need to use intermittent sealants or pads? How do we still maintain fire integrity? What about the terminal tightness? What's best practice for TT systems with it being metal? And also, because of it being metal, because of the ferromagnetic properties of steel, we need to still avoid the buildup of eddy currents.
At this point, we just want to run a small poll. Different from usual, I'm not going to give you too much choice this time. It's simply a yes or a no answer, if you would please. And the question really is, how many of you tuning in tonight actually do use torque screwdrivers?
Great, so I've launched that poll on behalf of Paul and Gareth. So do you use a torque screwdriver, yes or no? And just give a couple more seconds for the last few people to vote. That's great. I'll close that down and launch the results.
I must admit, it's always interesting to ask that question, because to be quite honest, on this poll, it's a pretty good split, nearly 50-50, in the fact that some do and some don't. Most don't, I must admit. You've got to remember that with torque screwdrivers, we at NAPIT don't naturally really enforce it. We're not going to enforce it in that respect. What we do is really say, make sure that you comply with the manufacturer's instructions, and one of the regulations is that you need to take manufacturer's instructions into account. Manufacturers of these new products are actually putting in the instructions, the Newton meter torque settings for different types of devices, and therefore what we need to do is make sure we comply with them. At the end of the day, they need to be tight. I come from a generation where torque screwdrivers weren't used a lot, don't forget, and we was always taught that terminals have to be tight, although terminals this day and age unfortunately can be a little bit over tight, and you can damage the threads, leading to breakdown of equipment, and therefore we're talking about the fires that unfortunately we're getting.
Yeah, so it's just a case of make sure it's tight but not over tight. You just have to just keep checking. So fortunately then, suitable products have come to our aid and help us make sure that we can satisfy the new regulations. So some of these products include the clamps for meter tails to make sure they're nice and secure. Yeah, we've also for the steel enclosures, we've got these oversized stuffing glands now. And something to be aware of is, if you are using these stuffing glands into a steel box, is make sure that the main tails go through the same hole as well as the associated earth, because of reducing those risks of eddy currents, you see. So they go through the same hole, so there's not the steel of the box to interfere with the magnetic fields that are created through those cables. So we've got the big type of ones for the mains, and also we've still got the 20mm type, such as the plastic or even steel themselves with the rubber seals. They're here to try and help us secure the cables, maintain the IP rating still, and secure them so they won't come loose should there be any movement. So yeah, we've got tail entry glands or even cable entry plates. Now the glands are very good for if you're coming through the top entry through the pre-made holes in them. However, if you're going back entry of the consumer units, there are cable grips that are in the back of there to try and help the cables coming loose. There we go. There's a picture now. There's a type of cable clamp there that sits nicely on top of the tails, so it keeps them nice and secure, reducing the risk of it coming loose, reducing the risk of getting hot and causing fires. Now then, so when we're doing our tails into the terminals, one of the trouble, which some of you might know or can see, is that the cables are round, yet they're going into a cable clamp which is square. So really you're putting a round peg into a square hole. So what we've found is, through ourselves and other members, is that try and mould the copper into a square type shape. So with your pliers, get on the end of the cable and gently mould it into a more of a flatter shape, so that when it goes into that terminal, it fills the terminal better, and that when you tighten up the terminal, it gets a good grip on it and it really secures it. And what we've found through testing is that's the best way, and it really does grip it really nice and secure. Now then, so why did it go to steel enclosures rather than plastic? Well, what we found is that, let's get over the myth of that the steel box is to contain the fire. That's not really the case. What it was is that they found that through sort of the cables getting hot, whether it's through poor workmanship, loose connections, overloading, or even a faulty products within the consumer unit, it was the enclosure itself, the plastic box itself, that was catching fire and giving fuel to create the fire in the first place. So what they said was to get rid of the plastic boxes and contain everything in a steel case. So what we've done is we've taken away that source of the fire, and by doing that, it drastically removed the any effects, if you like. The incident cases was reduced. So then, the regulation also contains 2 notes. However, Note 2 will be removed when the 18th edition is released. So, Note 1 was ferrous metal, such as steel, is deemed to be an example of a non-combustible material. And Note 2 was the implementation date for this regulation is the 1st of January, but does not preclude compliance with the regulation prior to that date. So in the 18th edition, because it will be a new edition, there's no need for Note 2 because we've all gone to the steel non-combustible cases.
And that really is it. Buy a reputable piece of equipment from a reputable wholesaler. Even ask the questions. Ask the questions whether it does come supplied with meter tail holding equipment such as the clamps. If not, install the large stuffing gland that Gareth showed you there. Ask also about the TT ready ones. The stuffing gland shown would actually be of great use in a TT system because obviously the stuffing gland and its by its manufacture is a very thick piece of equipment and will stop tails coming into contact with the metal enclosure, thus causing faults and shock potential. As long as you get a decent consumer unit, a metal consumer unit, and carry on doing what you've already done, then you will always comply with the regulations. The second subject is RCDs, residual current devices. Again, it brought up a few questions and a few topics and a few debates through the people that attended. Please remember that when we talk about RCDs through this, and whether RCDs are written, we're talking about any RCD device, RCBOs, RCCBs, RCD, standalone RCD 61008s themselves. An RCD has become a big part of our lives now because the new amendments have come out, and every time an amendment comes out or a new set of regulations, we end up employing more RCDs in more situations. You've got to remember that an RCD cannot be used as a sole means of protection. An RCD operates on earth faults only. It doesn't work on short circuits. It doesn't work on overloads. And for that instance, of course, you would also need to employ circuit breakers or fuses. Obviously, the RCBO does both jobs, but you always need fused circuit breaker. As I stated, when amendments come out, when there are changes, we always see more requirements for RCDs. BSM 671 includes RCDs in lots of places for 3 main reasons. The first one is fault protection. The second one there is additional protection, and last but not least is fire protection. It's best if we look at them all individually and go through it all in the way that the regs go through it. The first one is fault protection. RCDs can be used when the earth fault loop impedance is too high. As you guys will probably be aware of, TT systems have an inherent high ZE where we're using the earth path to be the general mass of earth, the concrete, the clay, the mud beneath our feet, and therefore that path is usually a very high resistance path back to the source earth. With TT systems and the fact that the regulations makes sure that you have to install a RCD at the origin of any TT system, then RCDs are employed in these places. Other places to put RCDs is when we have a high ZS. For example, a BS60898 Type B 20 amp circuit breaker has a maximum ZS of 2.19 ohms. If you are out on site doing an EICR, a periodic inspection, and you go and measure that ZS at the furthest point and you record a reading of 2.5 ohms, it's a non-compliance, and therefore we have to have some choices of what we're going to do. So a little poll, just to ask, again, a nice simple question, really is, what would you do in this case? Would you just stick an RCD straight on it? That will cure it. Or would you go around doing a little bit more fault finding, if you like, investigation work, not fault finding, but investigation work, to see whether we've got problems such as high R1 and R2s and high ZE values? So I'll open up the poll and we'll see what your responses are.
There we go. Thanks, Paul. So 2 options for you. What would you do in that situation? Fit the RCD straight away or investigate further problems? Just give you a couple more seconds to get voting. And that's great. We'll close that down and share the results.
Yeah, from the result, I must admit, it's a very pleasing result, I must admit, when you look at it. Well over 90% have decided that the best option is to investigate further. You've got to remember that if you're doing a periodic inspection and you do get high ZS values, it could be down to wear and tear of the installation. The installation itself could have loose joints. Even if you say a lighting circuit, there's lots of joints and sealing noses in lighting circuits. You only need one loose joint on the line or on the circuit protective conductor to increase that value, and of course a bit of investigation and a few tightening of joints can actually reduce the ZS values. It could be the fact, though, of course, that the circuit was designed a good few years ago, installed a good few years ago, and we have a system that was close to the maximum ZS then. Since then, of course, we've had new additions, new amendments, I should say, of the regulations, which have reduced ZSs as they go along, due to calculations using 230 volts instead of 240, and C-min coming in to make sure we get the full range of the circuit breaker operating. So this, again, could be a factor. And if that factor exists after your exploratory work, then we would end up fitting an RCD, and as long as that is tested accordingly and maintained, it will look after the high ZS values. The table in front of you, those that have looked through the regs will notice table 41.5 is a table to show the highest resistances that we can have in theory, and I'll say in theory, for RCDs on the left hand side to operate. It works on the 50 volts is dangerous in routine. If you have 50 volts and you divide it by 0.03 milliamps, you'll get 1666 ohms recurring, and therefore theoretically a 30 milliamp RCD should operate at that resistance if to avoid 50 volts being reached. Please remember, ZSs need to be as low as possible at all times to make sure that we comply with the regulations and we get protective devices, whether they be circuit breakers and fuses or RCDs, operating in the shortest possible time. Moving on to the second point, it's additional protection. Additional protection, if you read through the regs, is simply protection of life. And additional protection RCDs have come in more onerously as technology's got better, RCDs have got better. Then we're fitting more and more RCDs in more and more places. Excuse me. Places that come to mind, obviously, all sockets rated less than 20 amps, socket outlets rated less than 20 amps have to be on RCDs. Equipment outdoors, less than 32 amps on RCDs. Any equipment or circuits within a bathroom, running through a bathroom, have to be on 30 milliamp RCDs. Cables buried in walls less than 50 millimeters deep and not in mechanically earth protection have to be on 30 milliamp RCDs. And many instances in special locations. So as you can see, the RCDs are becoming very prevalent wherever we work, and these RCDs have to operate within 40 milliseconds. When we test them at 5 I delta N, that's 5 times the rating of the device. So for 30 milliamp, we test it at 150 milliamps, and it must trip within 40 milliseconds. And of course, we need RCD testers to do that. The last point is fire protection. Fire protection again is used throughout, mainly the special locations part of the regulations, part 7. Used mainly for fire. Regulation 705.422.7 is from agricultural and horticultural premises. It includes a part that states you should use a 300 milliamp RCD up front. And in 532 there is also sections for the protection against the risk of fire. RCDs for fire protection are installed in wooden barns, in stables, in agricultural and horticultural places where you get a lot of hay and dust and dry materials during the summer. Even thatched properties. The design of a thatched property may include in the specification that you should be putting some type of fire protection RCD up front. There are, of course, other considerations to think of when we're talking about RCDs. RCDs will operate. The term there, unwanted operation, is sometimes called nuisance tripping. It's something that the manufacturers, I must admit, don't like, because at the end of the day, nuisance tripping means the RCD is actually doing its job. All pieces of equipment leak to a point. Build-up of leakage will mean we can get above the 15 milliamp rating there, and things then start to get to a point where the RCDs can operate. It's not a question of the RCD being faulty. It's not really a question of the equipment you've installed on it being faulty. It's a question of not complying to the regulations, such as 531.2.4, which means we need to subdivide our circuits. We need to make sure that equipment is equally divided between circuits, and 314.1 is the division of installation. We install different circuits for different pieces of equipment, and that way we can control the leakage that happens on each individual circuit. We can also employ time delay RCDs. The S-type RCD, the selective type RCD, is used upstream, downstream of each other, and basically speaking, it will look after things for like discrimination. Talk about discrimination in a minute. Please remember, any RCD above 30 milliamps, and especially selective types, are not additional protection RCDs. They will not protect life. They will protect against fire. They will protect circuits, but they will not protect life. Discrimination is the ability of any protective device to operate in the right sequence, really, in the right preference. We do it with fuses. A fuse on a piece of apparatus in a plug top is supposed to go if that piece of apparatus goes faulty. A faulty equipment should not take out the supply authority's main fuse. The fuse should blow in order and in sequence, and basically speaking, that's what we do with RCDs as well. We select them in size, so that will operate in a sequence. A prime example is the TT system. All TT systems have to have an RCD, and if a circuit is feeding a consumer unit downstream, that circuit would need an RCD on it, 100 amp, 300 amp, 300 milliamp, sorry, I should say, selective one, and then at the further end we can put our distribution circuits on the TT system onto 30 milliamp RCDs, protection for additional protection, sockets, lighting, etc. So they blow in the right order, they operate in the right order, because the RCD downstream is S-type and will obviously take a lot longer to operate. RCDs themselves, as I say, have improved lately, and manufacturers now are putting more and more signage on them. The sign in front of you is a time delay selective type RCD. This symbol means that RCD can be selected for different times operating, and as you can see from the following, we have different symbols for different types of RCDs now. The one we're all used to is generally the RCD that works on AC. It is purely works on AC. Any faults over on a 30 milliamp RCD, any faults coming up to 27 milliamps, 30 milliamps will operate this device, and we're used to fitting them. What we are getting now is more equipment that has inverters in them. We're now fitting PV systems on roofs, we're fitting electric vehicle charging equipment. These use and generate DC, and manufacturers are actually often asking installers to install the following types of RCD, and they are a type A and a type B. Please try not to get these confused with type B's, C's and D's circuit breakers. They're not. These are different types, and these are for RCDs only. The type A works on a pulsating DC, and the type B detects pulsating DC and even steady DC. And the symbols you see on the right hand side are the symbols you would see on these devices. Always check manufacturer's instructions. The manufacturers of the PV inverter, the manufacturers of the electric vehicle charging equipment, the car itself, will recommend what size type RCD to install. So again, we'll go back to the regulations right at the beginning of the book. Regulation 134.1 states, good workmanship by skilled or instructed persons and proper materials shall be used, and you need to take into account manufacturer's instructions. So taking care of that will mean your installations are A-OK, both RCD wise and consumer unit wise. With that, it's really, thank you very much for attending. As I say, this was the expo slides. If you have any questions, we'll take them. If you need any more help, please remember that we are available, and the technical helpline is available 5 days a week, and they're there to help you with any question that you care to ring in and ask.
That's great. Thank you very much, Paul and Gareth. You'll be pleased to hear there are lots of questions to get through, and we've got lots of time, so please keep them coming in. The first one is from Ian. He's asking, most metal boxes don't have enough cutouts for cable glands. What options are available for protecting cables as they enter the enclosure?
Right, okay, so yeah, that can be a trouble sometimes. Yeah, I can sympathise with that. So if you find the case that you've not got enough holes with your stuffing glands, you could always cut a slot on the top and use a bit of trunking on top of there. As long as it covers all the hole that you've cut out, you are still satisfying the IP rating, you see. So you can use a trunking system, put your cables in that trunking so they're dressed nice and neatly, and then you can cut a slot in the top, as long as that cut that you've put in the metal enclosure is covered by the trunking.
Yeah, as long as the IP codes are maintained, yeah. What you've got to remember as well is a lot of manufacturers have done a lot of testing on these products, and it is the equipment inside that's catching fire and melting and causing the fire for the box to collapse, really. And people have done hot wire tests and ignited the inside of a consumer unit, both with the knockouts in place and even with the knockouts removed. The actual result was not much different, to be quite honest, in any way, shape or form. It was the collapsing of the plastic box that was the problem, and not the fact that there are holes in it. The holes are fine. There is no problem with that. It's the plastic box themselves that was catching fire. Next question.
Great, thank you. So second one from Tony. He's saying, if a client requests a replacement of his existing home consumer unit with a plastic version which he's already bought, is it correct to refuse to install it and to advise the purchase and installation of a metal unit?
Well, yeah, that is the case because because of the regulations. It's a case of we do have to either use a metal box or remember you can put it inside of a steel enclosure. So yes, you could use that plastic box as long as it is inside of a non-combustible unit.
Yeah. Got to comply with the regulations as they are written today, if you see what I mean.
Thank you. So do the stuffing glands need to be of a particular specification or just standard off-the-shelf ones okay?
Yeah, the ones off the shelf are more than adequate. Yeah, like I was trying to say, it was the plastic case itself that was catching, that was adding fuel to the fire, if you like. So the ones off the shelf are more than adequate. Yeah, they're really good. So you don't have to get anything specialist as far as we know. It's yeah, the ones from the wholesalers are more than good enough.
A lot of people I know, a lot of electricians I know, like the membrane grommets. They're like a blind grommet, only they've got a thin membrane at the top. You can just pierce it with a screwdriver, push the cable in. You're complying with the IP codes, you're complying with the fire integrity, and yeah, there's no problem.
Right, so if a consumer unit's being updated, especially in a non-RCD situation, should it also be placed in an accessible position? And is this a requirement or recommended?
No, it needs to be placed in an accessible position. All electrical equipment should be accessible for people to work on it, maintain it, to examine it, to test it. So wherever any piece of electrical equipment is, it needs to be accessible. There isn't really heights, if that's where the question is, of a height for a consumer unit. A consumer unit needs to be at a height that people can gain access to. Switches and sockets need to be between 450 and 1200, yeah, mil. You're really looking, Part M, the document that it's worked on for heights, does mention that any consumer unit with accessible pieces of equipment that need to be operated by the customer, such as circuit breakers, things like that, RCDs, should be at a height of between 1.35 and 1.45 millimeters meters above the ground, yeah. But it needs to be accessible.
One thing, I've never met anybody yet who pushes the RCD test button every 3 months, or even at all. Any thoughts?
Well, we sympathise with that. Yeah, you know, guilty myself. I wouldn't press mine every 3 months. You know, however, it is recommended, but it's a case of maintainability really, because it is there to try and help maintain the longevity of the piece of equipment.
The springs obviously will become very, very rigid if it's not maintained, and that piece of equipment, as I stated, is if it's an additional protection RCD, 30 milliamp RCD, it's going to protect life. If it's solid and will not move, and there is a fault, and that does not operate, then it won't save life. So it does need to be maintained. I should imagine every electrician out there, again, doesn't test theirs 4 times a year. I'm sure they don't. But that's what the recommended manufacturers is. If it doesn't operate and you haven't maintained it, I'm afraid that would be a maintenance issue, a maintenance problem.
Thank you. So we've got one from Danny about a TT system. Do you need to replace the main switch for an RCD type to protect the consumer unit internal tails before they are terminated into the consumer unit RCDs, as those are normally single insulated?
I must admit that's a very good question. It's a question that did come up on a few of the expos we had. A lot of manufacturers are developing or putting together what they call a TT ready consumer unit, where the main switch is actually a 100 milliamp time delay RCD with the 30 milliamp RCDs, RCBOs put on the sub-circuits, and that would perfectly solve that problem. You've got the 100 milliamp RCD looking after the internal workings of the internal conductors of the consumer unit, if you like, with the circuits protected by RCBOs for additional protection. Yeah, I think that's about it. Yeah.
Yeah. What it is, you've got to remember what RCD you're putting in, what it's protecting. So if it's for fault protection, then yes.
That's great, thank you. So when an installation is old but not obsolete, so i.e. the insulation is okay, do you have to improve circuit discrimination when replacing the consumer unit?
When you say improve circuit discrimination, then it's a question I'm not quite understanding which way they're going. The discrimination needs to be maintained because, again, you're working to the regulations as they stand today. So any changes you do should comply with today's regulations, which is obviously Amendment 3. And discrimination has been a part of the regulations, as far as I know, since I've been working on the 14th edition. So, yeah, whatever device you use, they should discriminate downline in the right order. And really, it would be down to you as the installer to make sure that that happens, yeah.
Okay, I think this is 2 questions in one, so he's getting double value for his money here. Are the plastic stuffing glands compliant for the use of meter tails going into the distribution board? And secondly, also, should we be installing RCBOs instead of split load DBs?
The stuffing glands, yeah, the plastic ones are perfectly fine. Yeah, that's a good thing to do. The RCBOs do help with the subdivision of circuits. They absolutely do help with that. In some cases, depending on the design of the installation, RCBOs are definitely better. But there's nothing to say that you have to use them over a split load board. There's nothing wrong with a split load board. Like I was saying, it's totally down to the design, really. Whatever's best for that situation and installation.
Yeah, the regulations state that you should split the regulation and subdivision of circuits is in the regulations, and that is the reason we went to a split load board, if you like, a split load 2 RCDs. 2 RCDs is the minimum, because if you're not allowed to lose the whole of the installation with a fault, if you've got certain certain circuit breakers on an RCD, you could lose 1/2 of the installation, but you've always got the other half. The installation of RCBOs, just as Gareth said, it makes it a lot easier. With the discrimination, you've only lost just 1 circuit rather than a bank of circuits, but they're compliant both ways.
Okay, so this is from Sean. What do you recommend for consumer units where most cables are coming in from the back and the wall behind the unit is combustible, i.e. a stud wall?
You can get intumescent putties, plates, pads. Always make sure that if you are doing that and it is a stud wall at the back, which is latten plaster, that you are installing a consumer unit that will allow you to put that intumescent pad in the back. Some manufacturers don't recommend it's with their pieces of equipment. Some manufacturers do. So it's one of those occasions where if you do find you've got that installation and you are bringing the cables in the back, you need to go to the wholesaler and ask the question, or choose a consumer unit that would allow you to put intumescent pads and sealant in the back, because you are liable to do that, but it has to be on the manufacturer's recommendations.
Okay, so when installing a metal board, can we butt up to plastic 3-inch trunking and use open grommets?
Yeah, you can do that, because what it was is it was the enclosure itself. I understand what you're trying to say. Yeah, I've got the metal next to the plastic. It's because the switchgear is contained inside that metal box, so the trunking is outside of that. You see, so it shouldn't be a problem.
If things go wrong, and things do go wrong, and terminals are loose, and you do get heat produced, the idea of the metal consumer unit is just to stop that heat spreading. That's all. It's certainly going to affect the installation. Things will not work. Things will not operate. Things will break down, yes, but it won't spread fire and burst into flames. That's the idea of it.
If fitting tail stuffing glands on a TT system, do you still need to fit a standalone RCD prior to the DB?
Not prior to it, no. No, the tails will be looked after. As long as you shouldn't be going too far away. You don't want to be more than 3 meters of tail. The tail themselves needs to be a double insulated tail. The gland needs to be a manufactured gland, such as the ones we've got here. Yeah. These manufactured glands are so thick-walled that the tails cannot touch the consumer unit sides. The tails themselves need to be protected. Obviously, you don't want to be putting them in areas where they can be mechanically damaged and things like that, so they need to be clipped and supported to make sure that you're not putting any strain on any termination or even on the meter itself. So clipping them back to the board, to the wall, will be of great benefit.
So when testing upstream RCD with the same rating as downstream, is it okay to use the incoming neutral as the earth return path for the tester?
That's a good one.
To me, that sounds like a discrimination problem, because you shouldn't really have an RCD of the same value protecting another RCD of the same value. That's a discrimination thing. So you've got to sort of think about the installation method you've used. Why are you using that the primary RCD first to protect? What is it protecting? Is it for additional protection or even fault protection? Then what have you got on the end of that? So you should be testing your RCDs appropriately and taking a neutral out, and that's sort of playing a bit.
It's discrimination problem. Just as an example, you should have 100 milliamp RCD feeding the board, and then a 30 milliamp RCD within the sub-circuit of the consumer unit that you're testing. So one really shouldn't affect the other, and it should be okay.
Great. Can you use an open grommet for tail entry if the tails are secured to the wall before entry?
Well, that's an IP problem then. I think if you're using an open end grommet, remember if it's on the top surface, the maximum hole it's IP4X. So I'd say an open grommet is a no.
Especially on the top.
Especially on the top. If it's underneath, the limit's IP2X. If you're within that, then I can't see it being a problem. Yeah. But I personally, I think using an open-end grommet, would you make IP2X as a minimum?
If you can get your finger in it by the side of your tails, then certainly that's an IP problem. If the grommet is tight around the tails and the earthing conductor, and you can't get your finger in it, you've complied. So the answer is yes, the grommet is okay, but you've still got the issue of the strain on the terminations of the main switch, and yes, the clipping would be good, or you could support it in a bit of trunking underneath. But yeah, the IP problem needs to be addressed.
Great. So apologies if you've already answered this one, but are there any rules about using non-combustible backboards when changing consumer units?
It's like any electrical equipment. You should always be careful of what you are fitting the consumer unit to. The answer really is no, there isn't. Always fit it to a non-combustible surface if you can. As I said, Regulation 134, again, going back to that, it's good workmanship and proper materials. Even what you are installing to needs to be able to take the installation you put in it to. So it's just like doing anything. When you're clipping cables, you would clip them to a surface that will retain the clip and won't fall out in a few seconds and just dangle there. It is a question of making sure that whatever you're installing is installed to manufacture instructions, as I say, and to as preferably a non-combustible surface, brick, plaster.
Some of the smaller consumer units for garages are too small for the use of a gland for the tails and earth conductor, but are very often a TT system. Can you suggest another method for terminating tails and main earth where space is an issue?
Now that remember the metal board thing was for domestic premises, as in where the part of the house where you sort of live and sleep. So in the garage.
Unless the mains is in the garage and the garage is a part of the house, then that wouldn't be an issue, because if the garage is a detached garage, then a plastic consumer unit would do. All jobs have issues. I mean, if you're doing that, you'd probably be doing the steel wire armour feed anyway, and it'd be the steel wire armour gland that you'd be using. So as long as you can install the tails within the enclosure, the consumer unit, where you're putting no strain, the IP is fine. How you do it, there's several methods, obviously, but
it's a design thing.
It's a design thing, yeah.
You could get the appropriate, what's the equipment that's needed
for the job in hand, yeah.
Fantastic. So you're not getting off that easily, guys. We've still got a few questions to get through. How do I handle SWA cable to a remote location, e.g. a shed, whereby the shed will be a TT setup? Supply to it is PME.
Yeah, it's a different issue. It's not consumer units or RCDs, but it's a TT. If you're going to do it that way, then you would need an RCD up front. The steel wire armour would need an RCD feeding it through a circuit breaker as well. So you would need an RCD looking after that 100 milliamp, and then you could put 30 milliamp RCDs within the remote location for the sub-circuits.
Yeah, I think I heard a PME supplying the TT. So just make sure that at the far end you drop off that earth, so you're isolating the earth, so you're not connecting the PME to the TT. So just be sure you're isolating that, so it's not connecting through.
Really, what you're doing is you're installing two TT systems. Your main property is a TT. You would then feed your remote area with a steel wire armour on a say 100 milliamp time delay RCD. You could have a 100 milliamp normal 100 milliamp main switch within the remote location, and then you could have 30 milliamp RCDs then feeding your sub-circuits. Discrimination is kept, but as Gareth says, make each one a separate TT, and the steel wire armour is just really earth protection for the cable from the main house end.
Great. So this chap acknowledges it's a little bit off topic, but regarding the further investigation of high ZSs during an EICR, what would be considered reasonable steps given the customer's budget and time, etc., and reasonable steps for further investigation?
It is an EICR. It is a periodic, and this, of course, would be encompassed in the extent and limitations. What you're there to do is a report on the installation as you find it. If their budget is for you just to do that report, then you would have to record that high ZS, and if that was as far as I was going, it would be a code C2. And that C2 would obviously fail that installation, and then it would be up to the customer to then engage another electrician or re-employ you to find that out. It is a report, but again, use the extent and limitations on the EICR. You would need consultation with the customer. They may say go ahead and do a little bit of exploratory work, and if they don't want to, they've got a report that really is a failure, is an unsatisfactory. And we'll still need work doing on it, whichever way it is. But you're there to report on it. You're not there to fix it at that time, unless that is part of your extent.
Great, so thank you. So Angus is asking, previously when the 17th edition first came out, I asked for advice when upgrading a consumer unit which was fed from 16mm twin and earth submail, protected by a switch fuse in the meter box. The advice I received was that the sub-main was existing, and as such no additional RCD protection was needed in the meter box. A standard, in brackets metal, dual RCD consumer unit would be adequate. Is this still the case?
The problems you've got is how the 16mm twin and earth was installed and how it was designed in the first place. If it's installed within the fabric of the building and therefore is less than 50mm deep, unfortunately that requires a 30mA RCD on it. So your discrimination problem is an issue, and the whole design really is an issue. The other problem that you've probably got with it, it depends on whether any protective bonding is off the consumer unit, the far consumer unit that is, because the 16mm twin and earth earthing conductor may not be big enough for bonding requirements. So it may unfortunately be a reinstall of steel wire hammer, or
yeah, a bit of it depends how it's been installed really. It depends on its conditions. I mean, if the cable's surface and you can access the cable and see it, that might be the case. However, should it be clip direct, as in it's inside the wall itself, the fabric of the building, then but like I say, it's down to how it's been installed. Without sort of seeing it and investigating it a bit further, it's hard to sort of give an absolute answer for that, I'm afraid.
Okay, I'm conscious that we've got 6 minutes left, chaps, and loads of questions to get through, so we're going to do a quick fire round. If upgrading a consumer unit to contain 30mA RCDs, do you have to change existing RCD sockets to normal sockets?
That's a good question. There would be a discrimination problem. Yeah, the tripping times would be too close on the. Would it cause a problem? Yes, it could. In actual fact, yeah. If you've got a piece of equipment, it could take out both pieces of kit. Yeah, the RCD socket and the 30mA RCD. In actual fact, it would probably take out the protective device in the consumer unit first, because the other piece of the socket outlet itself would be of an older piece of kit, and the RCD will probably be a bit slower. Yeah? I don't know if you can.
Yeah. I mean, if you put in RCDs at the very beginning of the circuit, then there's actually no need for the sockets. But it's not. But personally, I don't think it's a case of that you have to switch them. You can still leave them in place. I suppose it's sort of belt and braces in a way, because you've got them both. And also the one on the socket would only do that particular one socket should that one go. I don't think it's a case of that you have to swap them. I'd say no, that it's not that you don't have to. It's just you've put an RCD at the front, and so you've got protection anyway for
you will have a discrimination. Yeah, you will have a discrimination problem, but it would probably just be affecting that socket circuit anyway. So it would be just that socket circuit it was affecting.
Great. So how do you build in discrimination on a domestic subboard when the cable supplying the subboard requires RCD protection?
Well, if it needs RCD protection, which RCD protection is it? I'm afraid that if it's installed in such a way that the cable supplying it does need additional protection, then you can't really get around it. You have to sort of make it that the cable supplying it, the distribution cable, has to be installed in such a way. I mean, it could be armoured, so then you could get away without using an RCD for additional protection. But if the distribution cable supplying it does need additional protection, then I'm afraid that's it.
You have got a problem, yeah, because the design is wrong. The design needs to be correctly done, whereas the circuit that feeds the consumer unit, the subboard, needs to be designed so it is steel wire armour, conduit, trunking, surface, things like that.
If you do an EICR and the board is plastic, is that a code 3?
Not necessarily, no.
If there's nothing wrong with the board, if there's no signs of overheating or damage, there's nothing actually wrong with it. It's just that if you're installing a new distribution board, then it has to comply to to the amended regulations.
Would I make a note of it? Yes, I would. Would I code it? No, I wouldn't. I would just point it out to the customer that I've put this observation on my EICR. I haven't coded it because I've checked it. I've checked tightness. Everything's okay. I can see no signs of thermal damage or anything like that. It doesn't comply in whole to the regulations as they stand today, but it's a new regulation, and I've checked it, and I'm quite happy with it. And that's as far as I think it needs to go, yeah.
Okay, so we've got a couple more minutes. I'm going to push and squeeze some more in. Do metal consumer units need metal blank plates, or can we still use the insulated plastic type?
Yeah, insulated plastic types, that's fine. Nothing wrong with that.
Nothing wrong. Yeah.
Okay, short, sharp answer. We like that. If a 5 times RCD test comes back at 38 ms, is this okay?
Well, it's within 40, yeah. So it might be close to knuckle, but it's okay.
It passes, so it's okay. Would again? There's plenty of places on your EICR that you could put down that observed it. It's getting a bit tight, and you really need to be keeping an eye on it.
Yeah, maybe your frequency of testing might need to be improved, but otherwise it passes.
So it passes.
For TT systems on a split board, if I change the incoming isolator switch to a time delay RCD, does this comply with the reg?
It would comply with the regs in looking after the board itself. It wouldn't comply with the regs for the sub-circuits, because the sub-circuits would need 30 milliamp RCD for sockets, cables buried in walls, circuits within bathrooms, etc. And the 100 milliamp RCD is not for additional protection.
With regards to accessible locations of consumer units, this chap finds a lot in cupboards in kitchens. If he's just doing minor works like replacing MCBs, should he just leave it where it is?
Yep. And that's the answer to that one, yeah. And make a comment, yes, they put them in kitchen cupboards, to be quite honest. Mine's in a kitchen cupboard.
I mean normally the board would have been there before the kitchen cupboard.
It was, yeah. Mine's in a kitchen cupboard, and that's where it is. And yes, you can make a note of it. It would need to be checked, don't get me wrong, for IP codes, for signs of damage, for signs of external influences, and things like that. But as long as they're happy with it, there's no reason why they can't work on it now.
Grommets, do they need to be of a specific fire-resistant material or a standard rubber type?
Yep. Standard rubber type, as long as the IP codes are complied with.
Thank you. When extending an old circuit, if the ZS is over the maximum tabled reading, is it okay to install an RCD and the circuit can be signed off and left in service?
No, because you are designing a circuit, and the circuit is non-compliant, and what you're doing is extending a non-compliant circuit. If you can investigate it and find the reason for the high ZS, that's fine. If it is just a high ZS circuit and you extend it, you're only going to make it worse. So you may have to install a new circuit for your piece of equipment.
Great. Is it safe to use silicon to maintain the IP rating of a grommet that has room and not full with cables?
Yeah, it is. You can use silicon. It would depend on the manufacture of the silicon and whether it would actually eat the cable. You've got to make sure that you're using the right equipment for the right job. Some products actually dissolve plastic and things like that, so you'd have to be careful.
Yeah, I mean, if that's a last resort, then that's a last resort. But I personally, I
was going to say a stuffing gland.
Yeah, if you can use a stuffing gland, that's a lot better. Yeah,
yeah. I remember grommet. Yeah.
If a 30 milliamp RCD fails the push test but does respond to MFT test, should it still be swapped out?
Yeah, because it's a functional test and it's failed the test. If it fails that, it's because if you like, I think if you've gone to do the the actual test with your tester, you've sort of tried to wake it up first by pressing that button. Yeah. And I can imagine that after you've done that test, then you go and press the functional button, it probably would work that second time. But remember, it's there for additional protection to protect life. You only get one sort of chance, so it should work first time.
I always personally like to do it on a periodic inspection. If I'm doing a periodic inspection on an RCD, I will use my tester before I press the button. I don't want to give it a chance of loosening it up. I want to see if it actually operates under my simulated fault conditions and saves life. If it doesn't, it would need changing.
Right, so I know we've reached time, but I'm going to carry on for a couple more minutes if the presenters don't mind, just to squeeze some more questions in, because I know that's why you guys are all still here and staying with us. So can I fit a plastic consumer unit in an IP-rated weather box? I have 3 flats where the consumer units are in the outside porch and need changing.
If the IP box is steel of a non-combustible material, then that is possible. Remember, it's still a domestic premises, so as long as it's accessible inside the steel enclosure, if you like, that's non-combustible, then that is possible by the sound of it.
It would have to be a very good external influence protected box. That's all I'll say.
Oh, outside. Oh.
Yeah, outside. Yeah, because you've got a lot of external influences with moisture, changes in temperature, and things like that. And again, outside is not a really accessible place for customers that have any problems to go out in the middle of the night, wet through, trying to re-energize electrical equipment. Really, outside is not a good place for a consumer unit now.
So I have an installation where it was designed before the metal consumer unit regulation came into force, and a plastic consumer unit was fitted, but the installation is not yet complete. Do I need to replace the consumer unit with a metal type now?
No, as long as you can prove the design was started for that. What you've got to do is, as long as you've got some documentation that states it was designed, the specification, some type of invoices for the piece of equipment you bought for it, then there's no problem there. It would need to be noted on the certification when you've finished it, but as long as you put down comments on the existing installation that it was designed to a previous set of regulations before Amendment 3 came out, and you can prove that, there's no problem.
Is there an IP requirement for the bottom of a consumer unit?
Yeah, IP2X.
IP2X, yeah. IP2X for any electrical equipment approach from front, sides, bottom, and IP4X from the top, which is a 1 millimeter diameter wire. Yeah.
Final question then. A consumer unit in a cold cellar was recently replaced. Now it attracts a high amount of condensation. And I know this was a question that came up frequently at the expo, so any advice?
To me, it sounds like an external influence problem. Is it really in the right place? Maybe not. If it's getting covered in condensation, that's a bit of a problem. I should imagine there's another problem going off there causing that condensation, to be fair.
It's true, yeah. Again, you see, the metal consumer unit can actually go inside a plastic box. So as long as the metal consumer unit is metal, it could go in a plastic box, and as vice versa happens, you can do it that way. So the plastic box would protect it against some of the dampness. I don't think all of it, because if you've got damp's going to get in no matter what. But so yeah, it's a sighting issue more than anything else.
That's great. So thank you very much, everyone, for joining us this evening. As Paul said, if any of your questions weren't answered, please, we've got our technical helpline. It's available 9 to 5, 5 days a week for you to call and ask your questions. We will also be collating all the questions on these subjects, on the Expo presentation subjects from all of the different expos, but also the webinars, and we'll be putting those, once answered, up on the member downloads area in an FAQ section, so hopefully that should help you as well. So all that's left to say is I'll leave the webinar running for a couple of minutes so that you can download the handouts, this presentation and the certificate from the handout section, and we hope to see you next time. So thank you very much.
Thank you very much.
Thank you. Bye.
Cheers now.